Hey everybody, welcome to Physics 1403, Stars and Galaxies. I want to make a very short video about the evolution of galaxies. In a previous video, I talked about the different types of galaxies, just real quick. Elliptical galaxies, which look like globular structures. Irregular galaxies, which are galaxies that are slightly, well, they don't seem to have any sort of internal structure, and they are oftentimes subject to external tidal forces, forces that are preventing them from forming an internal structure or ripping apart the internal structure that they have. Spiral galaxies and barred spiral galaxies, this is what most people think of when they think of galaxies, that those beautiful arches, those spirals that come off of that central bulge or central bar and form that bright blue appearance that they often have. All right, but why do different galaxies have different shapes? Okay, so over here I've drawn just a very simple graph, and it really kind of I wanted to use this. We'll edit that part out. So over here I've drawn a simple graph to try to explain why some galaxies form arms and some galaxies don't. And what it really has to do with is the rate of star birth. Okay, so if in the early years of a galaxy, the rate of star birth is extremely high, like considerably higher than in the Milky Way, but it uses up all of that dust and it uses up all of that gas, and then it drops off very quickly until it kind of peaks and almost seems to stop. It's so slow. All right, that's going to form an elliptical galaxy. Elliptical galaxies are formed because the star birth rate is so low. And if it started with approximately the same amount of dust as its mass, then it meant that it used up all that extra dust early on in its history. And so without that extra dust, without that those gas to have new star birth, it just sort of forms a blob. Spiral galaxies, the rate of stellar birth is much lower early in its history. It kind of peaks a little bit at about a billion and a half years or so, and then it just sort of gradually goes down over the years. It's never as high as those early years of the elliptical galaxies. And this means that there's a lot more gases that are available. And that is, as it goes through, and yes, it's still burning through the gas reserves that it has, but it's burning through them in a more constant and a slower rate. So you're constantly going to be able to have those new stars that are being formed along those spiral arms, giving them that very distinctive shape. As for why some are barred and some are not barred, that probably has to do with the amount of dark matter that is found in that galaxy. Remember, dark matter it has mass, it affects gravity, it affects the orbit of these stars, it affects the orbits of galaxies around each other, but we haven't been able to observe it directly. And as a result of that, that's why we call it dark matter. And so a barred galaxy probably has a higher quantity, higher percentage of its mass is actually dark matter versus a spiral galaxy. And there's also some idea that a barred galaxy may be because it's a natural phenomenon. If this star birth was lower at first, then it gave more time for dust to accumulate in the center of that gravity, or the sensor, excuse me, gave more time for that dust to accumulate in the center of that galaxy, which gives it that bar shape in the center. And gave it an area where there's plenty of star birth and old stars, new stars, that sort of thing, right? Without sacrificing the amount of dust and gases that are available to make new stars along those arms. Whereas a spiral galaxy, it hasn't accumulated all that dust in the center as much as a barred galaxy has. All right, so there you have it. Very short video on the evolution of galaxies. It's all about the birth rate. If it's really high to start with, it's going to taper off very quickly. and form an elliptical galaxy where if it's lower to start with, it'll peak a little bit and then slowly decline over billions of years and it's going to form a spiral galaxy. Until then, I'll see you next video.